last thing we're going to do in this particular section is talk a little bit more about the change of base formula, specifically using it to graph. Alright, graphing logarithms and exponentials, if it's not base 10 or base e, the natural base, can be difficult. Well, we make it undifficult by using the base 10 and base e in our change of base formula. Alright, so to graph this, or you can use your inverse properties, which the natural log of 2 is one we actually graphed already. If you go back and look at when I introduced logarithms, this is the one where we used the fact that this was 2 raised to the y equals x, the inverse of y equals 2 to the x. But what if I want to graph it on the calculator? Alright, so hopefully you have your graphing calculator out. I no longer have, the graphing calculator hasn't been working on my tablet, so on your graphing calculator, so hopefully you have your graphing calculator, you're going to hit your y equals, use a standard window, and your y1 plug in. So what we're going to plug in, now some calculators you can find log base 2 fairly easy, especially if you get like an Inspire or one of those. But if you don't have a calculator where you've got the log base 2 that's really easy to find, well, we'll use the change of base formula. I can change this to any base that I want, so I can either change it to base 10 or base natural log, and so I'll do base 10, so it'd be the log of 2, log base 10 of 2, divided by log base 10 of x. So when you go to plug this in the calculator, it's your log key 2 divided by your log key x. It's the exact same function as log base 2 of x. That is the log base 2 of x. But we can't type it in. Log base 2 is easy. So what you do on your calculator, so this is what you're going to type into your graphing part of your calculator. And then standard window should work fine. If you graph it in the standard window, it should be the form we had before. Now, the calculator is slightly flawed. You do have to remember the behavior of it. Alright, the asymptote here at x equals 0, it goes through the point 1, 0. Slowly grows, and then the calculator looks like it stops, but it really doesn't. What happens is it gets so close to the axis you can't see it anymore. It's really hard for me to graph it, but it is continuing down forever. It's shooting down forever. You just can't tell that because when you get so close to the x-axis, so the y-axis, the x equals 0 line, you can't see it anymore. And so just make sure you're aware of that with your calculator. Your calculator is a little flawed in that way. It doesn't show the shooting off to negative infinity very well. But it is shooting off to negative infinity. And it is approaching this asymptote x equals 0. Alright, the next example, kind of keep that in mind in the next example as well. So graphing this function, so again, that one actually I can type in. Right, a natural log is in my function, so I can hit my y1, type in the ln of x squared, make sure you put parentheses around the x squared minus 9. This was the flip of the one we found the domain of earlier. Alright, so what you do have to be careful of it, the calculator has issues once it's approaching the asymptote. Alright, the asymptote's where it's approaching the 0. Remember, the natural log does not exist at 0, so it does not exist at 3 and at negative 3. Right? 3 and negative 3 would actually be asymptotes in this case. X equals negative 3, x equals 3. Right? If I try to plug 3 and negative 3, you get an error, right? Because that will give me 0. And so what happens is those zeros are my asymptotes. And so the behavior of the graph, it looks a little weird, because as it's approaching it, it's really hard once it gets close to that 0. The calculator is flawed in that way. So when you're graphing it on your calculator, it looks like it stops there. It doesn't. It doesn't stop midair. It continues to approach that asymptote, and it shoots down to negative infinity. It's continuing to move down and approach that asymptote, that 0, at x equals 3. Alright, so it's got an asymptote at x equals 3 and x equals negative 3, where it's 0, where it'll have 0 inside. Same thing over here. Your calculator's flawed. It looks like it stops midway, but it doesn't. It really is continuing down to negative infinity. So you have to be aware of that with logarithms and calculators when you go to graph them on your calculator. So Just make sure you're aware of that. All right, last example is log base 3. All right, so again, if you've got a calculator, you can type log base 3 and feel free to type log base 3. And if your calculator is like an 83, 84 where it's not easy to find, it does exist, and if you want to look at videos and see how to do that, it is buried inside a catalog. You can find it. But if you don't want to go unbury it, you can rewrite this using the change of base. I can change that to the log of x cubed plus x squared minus 2 divided by the log of the base. And type it in the calculator that way. I believe a standard window should work just fine. Alright, so if you leave it in a standard window, it should graph. Alright, and again, it's moved over. It has sort of this shape. Actually, it's growing a little faster than that. Alright, but there is the shape of it. It is shooting down to negative infinity on this. So again, it does look like the calculator does look like it stopped. It doesn't stop. Right? It does slowly shoot down to negative infinity. So make sure you're careful with that. Right? It is shooting down to negative infinity there. Alright, so it doesn't just stop. There's an arrow, it does shoot down. And again, the calculator's flawed that way. When it approaches that 0, there is an asymptote there. And when it approaches that asymptote, it has error, but it's approaching it and shooting off down to negative infinity. Alright, that's the last example that, again, you should practice graphing those and be aware of the flaws in your graphing calculator. Next thing we're going to do is, well, we're going to use the graphing calculator to help us solve complex equations. Alright, so we're going to graph and solve graphically. Alright, that's the next steps.